Welcome to the Explainer. Every so often, a single document comes along that's, well, it's more than just words on a page. It's like a blueprint for the future, unlocking doors nobody even knew were there. Today, we're diving deep into one of the most important blueprints in modern tech, the Ethereum Whitepaper. So, back in 2009, Bitcoin landed and completely changed the game, right? It gave us this radical new idea of digital money. But then, just a couple of years later, this young programmer, Vitalik Buterin, he looks at the tech behind Bitcoin, the blockchain, and asks this huge question. He asked, what if this global decentralized ledger could be used for pretty much anything? And that single question, that's what led to his 2014 white paper. Now, this thing wasn't just some proposal for a Bitcoin 2.0 or a slightly better version. No way. It was a blueprint for something completely different. A whole new kind of platform, a next-generation platform for what we now call smart contracts and decentralized apps. All right, let's break this quote down, because this right here, this is the core of the whole idea. Don't worry about Turing complete for now. We'll get to that. The big thing to get your head around is that Ethereum was never meant to be just one specific thing. Instead, think of it like a giant shared global computer, a blank canvas, really, that anyone, anywhere could use to build whatever they wanted on top of it. So, to really get why this was such a massive deal, we got to take a quick step back and look at what came first. I mean, Bitcoin was the big star, for sure, but it didn't just appear out of nowhere. It was definitely standing on the shoulders of giants. You see, this idea of decentralized digital money, it wasn't new. People have been chipping away at this problem for decades. But, as you can see here, it was Satoshi Nakamoto who finally put all the pieces together in 2009. It was brilliant, really. They took all these existing concepts, things like computational puzzles and proofs of work, and wove them together to create the world's first actually decentralized digital currency. So, how does Bitcoin actually work? Well, at its heart, the white paper describes it as a state transition system. Now, that sounds super technical, I know, but the concept is actually pretty simple. Just picture a giant public spreadsheet that lists who owns what. That's the state, okay? So when I send you some Bitcoin, that's a transaction. That transaction updates the spreadsheet to a new correct list of who owns what. And that's the new state. It's basically a universal bank ledger, but one that's shared and secured by a massive global network instead of a single bank. The way Bitcoin does this is with something called a UTXO model. The best analogy is just to think of it like physical cash, right? If you have a $20 bill, that's a single output, and you buy a $5 coffee, the cashier doesn't rip a piece off your 20, you give them the whole thing, and you get $15 back in change as new bills. That's pretty much how Bitcoin works. It's a really elegant system, and it's absolutely perfect for the one thing it was designed to do: move value from A to B securely. But here's the catch. That laser focus was also its biggest weakness. The whole system was so perfectly built for digital cash that trying to make it do, well, anything else was a huge pain. So that brings us back to the big question. What if you wanted that global ledger to do more than just track money? Now, to be fair, Bitcoin wasn't totally rigid. It did have a very basic scripting language. But the problem was, whenever developers tried to build anything even slightly more complicated on it, they just kept slamming into walls. The language was kept simple on purpose, for security reasons, which makes sense. But that same simplicity ended up being a creative straitjacket. And this is where Buterin's white paper just nails it. It pinpoints exactly what those walls were.
First, it wasn't Turing complete. That just means it couldn't do things like loops, which are fundamental for, most computer programs. It was also value blind. A script had no idea how much Bitcoin was even being sent in a transaction. Wild, right? Then there was the lack of state. A contract couldn't remember anything from one transaction to the next. And finally, it was blockchain blind. It couldn't even look at basic data from its own blockchain, like a timestamp. Any one of these is a major problem, but altogether, they were a complete dead end for building anything dynamic.
And this brings us right back to Ethereum. Because it wasn't just an improvement, it was designed from the ground up to be the solution to all four of those limitations. To be, in essence, a true world computer. So really, the absolute key innovation was a total shift in mindset. If Bitcoin was like a pocket calculator, amazing at doing one very specific job, Ethereum was designed to be a general-purpose computer, a platform where you could, in theory, run any program you could dream up. And this really gets to the heart of the architectural change. Bitcoin's cash model, the UTXOs, it has no memory. But Ethereum, it introduced the idea of accounts. And these are much more like your bank account. They don't just have a balance, they have storage, a memory. And that one thing, the ability for an account to remember stuff from one transaction to the next, that's what blew the doors wide open for complex applications. And because these accounts could be controlled by code, not just people, that gave birth to the idea of smart contracts. The white paper actually calls them autonomous agents, which is a cool way to put it. A really good analogy is a digital vending machine. You put in a specific input, say a transaction, and it automatically spits out a pre-programmed result. No cashier, no middleman, just code doing its thing. Now, to make these smart contracts powerful enough, Ethereum's programming language was made Turing complete. This was the direct answer to Bitcoin's biggest programming limit. It meant developers could finally use all the normal tools in their toolbox. Loops, if-then statements, all of it. Basically, the creative handcuffs were off. The new rule was, if you can code it for a regular computer, you can probably code it to run on this new global one. Of course, a computer that can run any program has a pretty obvious and dangerous flaw. What stops someone from telling it to run a program that just never ends? An infinite loop could grind the entire world computer to a halt. The solution to this was absolutely brilliant: the concept of gas. Think of it like this. Every single step of a calculation, every little instruction costs a tiny, tiny fee. Gas is literally the fuel that makes the network run, and it makes it way too expensive for an attacker or even just a buggy program to clog up the system. It's a really elegant fix. All right, so let's recap. We've got this global computer, it's programmable with a full-fledged language, and it's fueled by gas to stop it from breaking. So what? What does that let you do? What can you actually build with this? Well, this is where things get really, really interesting. The white paper wasn't just a dry technical spec sheet. It was more like a treasure map, pointing the way to a whole universe of new ideas, all built on top of this one foundational layer. For instance, token systems. With Ethereum, making your own custom currency or digital asset suddenly became, well, almost easy. A token is really just a smart contract that's running a simple little database, a list of who owns how many. And you could create tokens to represent pretty much anything: shares in a company, tickets to a concert, special items in a video game, you name it. Or you could go way beyond that and build some seriously complex financial instruments. Take this example of a hedging contract. You've got two people who lock up some funds in a smart contract. The contract itself can then check an outside data source, like the price of ETH versus the dollar. And then, after a certain amount of time,
It automatically pays out according to the rules they agreed on at the start. I mean, think about what that replaces. There's no bank, no broker, no third-party clearinghouse. It's just pure code, executing an agreement exactly as written.
But the vision went even further than that. Why stop at contracts? Why not build entire organizations on the blockchain? The white paper calls these DAOs, or decentralized autonomous organizations. I mean, just imagine a company where its rulebook, its bylaws, are all just code, and where shareholder votes are just transactions on the network. It's literally an organization that runs itself based on a transparent set of rules. And that, right there, is the real takeaway. This quote makes it so clear. The goal was never to build one killer app. The goal was to build the foundation, the ground floor for a whole new kind of internet, one that's more decentralized, a layer that could support thousands of new protocols. Financial ones, sure, but non-financial ones too. Things that no one had even thought of yet. So that initial vision from 2014, it sparked a global movement, it created an entire industry. It gave us the blueprint for this decentralized world computer. But the biggest question the paper asks is one we're all still trying to answer today. The foundation has been poured, the framework is up, but what are we, all of us, going to choose to build on it? And that, I think, is still the most fascinating question